Dear students, today we are going to start matrix, and this is of class 11, and then now we are going to define a matrix. What is a matrix? You know about matrix because you already read in class 10 also about the matrix. तर जो विद्यार्थी भाइ बहिनीले अप्सनल म्याथ लिनुभएको थिएन त्यो भने म्याट्रिक्सको थाहा नहुन पनि सक्छ। त्यसकारणले हामी म्याट्रिक्सको डेफिनेसनबाटै सुरु गर्दैछौँ। अब व्हाट इज अ म्याट्रिक्स? म्याट्रिक्स केलाई भनिन्छ त? म्याट्रिक्स इज अ कलेक्सन अफ नम्बर अरेन्ज इन टु अ फिक्स नम्बर अफ रोज एन्ड कलम्स। हेर्नुहोस् है त, म्याट्रिक्स matrix is the collection of numbers arranged into a fixed number of rows and columns, अथवा सिंगल रो अथवा सिंगल कलम पनि हुन सक्छ। यसकारण यो म्याट्रिक्स हेर्नुस् है त, म्याट्रिक्स इज अ कलेक्सन अफ नम्बर। सपोज 2 3 4 5 6 7 8 9 यस्तै मानौ 12 15 यस्ता नम्बरहरू हुन सक्छन्, अथवा नम्बर्स नभइकिन यार सम लेटर्स अल्सो हुन सक्छ। सपोज ए बी सी, अथवा कलेक्सन अफ अब्जेक्ट्स पनि भन्छौँ हामी, एरेन्ज इन अ रेक्ट्याङ्गुलर फर्म पनि भन्छौँ हामी, इन्टु अ फिक्स नम्बर अफ रोज एन्ड कलम्स। अब यो हेर्नुहोस् त, यहाँ फिक्स नम्बर अफ रोज र कलम्स भएन, त्यसकारणले यसलाई हामी म्याट्रिक्स भनिँदैन। यो म्याट्रिक्स इट इज नट अ म्याट्रिक्स। सो यसलाई हामी म्याट्रिक्सको रूपमा राख्नु पर्यो भने हाउ वी विल अरेन्ज? लेट्स लुक इट। 2 3 4 5 6 suppose, and then 7 8 9 12 15, and then there A and B again left, A B, and if we'll put like this is a matrix. यसरी यो म्याट्रिक्स चाहिँ हेर्नुस् त, यो कस्तो छ भने यसलाई हामी के भन्छौँ म्याट्रिक्सको? यसलाई हामी रो, दिस इज अ रो, एन्ड देन यसलाई हामी के भन्छौँ? यस्तो किसिमकोलाई हामी कलम। यसरी रो र कलमको फर्ममा एरेन्ज गरिएको नम्बर अथवा कुनै अब्जेक्टहरूको कलेक्सनलाई हामी के भन्छौँ? म्याट्रिक्स भन्छौँ। फर इक्जाम्पल 2 3 4 5, दिस इज अल्सो अ म्याट्रिक्स। सपोज ए बी एम एन अल्सो अ म्याट्रिक्स। तर म्याट्रिक्सभित्र हामी यसलाई चाहिँ स्मल लेटरले रिप्रेजेन्ट गरिन्छ। फेरि हेर्नुहोस् त, 2 3 सपोज 4 1, this is also a matrix. It means what types of bracket we have to use for the matrix, either this bracket or this bracket. So we have to either we can use this small bracket or we can use this big bracket. In matrix we can represent enclosed by this or this bracket. So matrix can be enclosed by this or this bracket. म्याट्रिक्सलाई हामी केले रिप्रेजेन्ट गर्छौँ? रिप्रेजेन्टेसन अफ म्याट्रिक्समा जस्तै यसलाई चाहिँ हामी म्याट्रिक्स रिप्रेजेन्ट अलवेज रिप्रेजेन्ट बाई क्यापिटल लेटर। सपोज ए, सपोज पी, सपोज एक्स, यसरी सपोज एन, अलवेज वी रिप्रेजेन्ट बाई म्याट्रिक्स बाई अ क्यापिटल लेटर लाइक दिस। And you know what are the elements of the matrix? Let's discuss about the elements of the matrix. Here this 2 is one element, this 3 is another one element, 4 is also another one element, this is 5 is also another element. So we are taking A is equal to 2 3 4 5. This is a matrix, and then this 2 is first element. We say this one is row and this one is column. How many row and column in this matrix? At first here is one row and then this is another one row. So here are 2 rows, and then how many columns? This is one column, this is next one, second column, 2 two columns, two rows and two columns. Suppose A is equal to 2 4. How many rows here? This is only one row. One row. This is also a matrix which have only one row, and then 1 2 column, one row and then two column, one row and two column. त्यस कारणले म्याट्रिक्स को यसरी आकोलाई हामी रो भन्छौं भने यसरी गएकोलाई हामी कलम भन्छौं. यसरी यो एउटा कलम, त्यस्तै यो अर्को कलम, त्यस्तै 2 3 4 सपोज 5 3 4 5 6. Okay, can you guess? This is P. How many rows and how many columns are here in this matrix? In this matrix we have this one row. This is हामी यसलाई first row भन्छौं, first row, and then this one is second row, and this one is first column, and this one is second column, and this one is third column, and this one is fourth column. So how many row and how many columns in this matrix? Now you can easily guess. Here are two rows and then here are two columns. So we can write it here, two row and then two column. This first one is row and second one is column, and we say this is the order of matrix. Order of this matrix is 2 by 2. This means two row and two column. So can you say what is the order of this matrix? Suppose 2 3 1 5. What is the order of this matrix? So you already guess this is first row, second row. So two row and then first column, second column, two row and two column. Dear students, here we have to look again. There is how many row? Two row, and then how many column? 1 2 3 4 columns. So we have to write two row and four column. Here is no two row and two column. Here is two row and four column. So we have to write first one is row, second one is column. So here is two row and two column. Suppose y is equals to 1 0 0 0 1 5 3 4 9. Can you guess how many row and how many column, or what is the order of this matrix? So to find the order of matrix, this is first row, second row, third row, first column, so 3 row, first column, second column, third column, so 3 row and 3 column. So its order of y is 3 by 3. We write 3 cross 3. So order of x, if we write like this, x 2 cross 2, so x is 2 by 2 matrix, 2 row and then 2 column matrix. So here also P we can write 2 by 4. It means P have 2 row and 4 column matrix. So can you guess here how many row and how many column here? A is equals to our 2 4. How many row here? One row, 1 2, 1 row, 2 column, 1 column, 2 column. So this is known as order of matrix. After knowing this order of matrix, and we have to know about the element of the matrix. Suppose a matrix A 2 1 4 7. Suppose this is, we know, 2 by 2 matrix, 2 row and then 2 column. This is the order of matrix. We already explained about this. This 2 is called first row, first column. So if we represent A is equals to A11, A12, A21, A22. So what is it mean? This is first row, first column. This is first row, second column. Second row, first column. Second row, second column. So comparing these two, A11 is equals to 2. If both matrices are A, then A11 is equals to 2. So this 2 is the first row and first column, the element of A. First row, first column is 2. So this one is the element of first row and second column. This A12 is this. So A12 is equal to 1, first row, second column, and then this one is second row, at second row, and then first column. So 4 is second, this first, second row, and then first column. So therefore A21 means second row, first column is equal to 4. And then 7 is second row and second column is equal to 7. So in this way we know the element of the matrix. Suppose 1 0 5 7 3 8 4 8 9 7 6 3. Suppose this is a matrix, P is equal to this matrix, and can you guess this 5 is which row and then which column? This is first row, first, second and third column. So this one is first row and third column. So we can write A13 is equals to 5, or 5 is equals to A13, means first row and third column. Similarly, can you guess the 7? 7 is first, second, third row, and then this one is third row and second, first, second column. Third row and second column is this one. So 7 is equals to A. Suppose A is the number, we can write B also instead of A. This is third row and then second column, we write like this. So we can represent element by this way, and then by generalizing we can write A11, A12, A13, A14, similarly A21, A22, A23, A24, similarly A31, A32, A33, A34, like this one. We can write Aij in general form. I means row, J means column. So Aij means Ai row and J column. So if we have one question, suppose Aij is equals to 3i minus 2j, suppose, then okay, we can write if this is equal to Aij is equal to 3i minus 2j, find 2 by 2 matrix. Suppose this is a question, then how can we solve this question with the help of this knowledge? Okay, let's look here. Okay, to solve this question, we have Aij is given 3i minus 2j. We have here 2 by 2 matrix. Let the 2 by 2 matrix be A11, A12, A21, A22. This is 2 by 2 matrix. So we have to find A11 first. So I is also 1, J is also 1, to find A11. Therefore A11 is equals to, here is 3 times I is 1 minus 2 times J is also 1. So this is equal to 3 minus 2, that one is 1. So this A11 is 1. We have to find this matrix. Okay, and then A12. For A12, I think you already guess how to find A12. So if we have to put it, I is 1, J is 2, this one is I, this one is J. So 3 times, here is I means 1 minus 2 times J is 2. So 3 minus 4, this one is minus 1. So this is minus 1. We found this and this. Now A21 is equal to, we have 3 times, here is I, this one is J. So I is 2 minus 2 times J is, because 3i minus 2j, we have here 2j. Instead of j we have to write 1. So 3 times 2 is 6 minus 2 is equal to 4. So we can write it here 4. Again we have to find A22. That one is A22 is equal to 3 times 2 minus 2 times j is also 2, I is also 2, j is also 2, so 2 and 2. So 6 minus 4, that one is 2. So the required, this is the required 2 by 2 matrix. In this way we can find the 2 by 2 matrix also. I think you know about the elements of the matrix. Students, now we are going to study about the types of matrix. Types of matrix. We have different types of matrix. First one is row matrix. Matrix which have only one row is called row matrix. Matrix which have only one row भन्नाले हेर्नुस् है त, suppose 2 and then 3, here is 2 3, only one row is called row matrix. Column चाहिँ 2 वटा छ तर यसको row चाहिँ only 1 छ, so this is called example of row matrix. Or we can give another one, 2, this is also example of row matrix. Or 3 4 5, suppose this is also only one row, this is also example of row matrix. So matrix which have only one row is called row matrix. Similarly, next one, column matrix. Matrix which have only one column is called column matrix. For example, suppose 1 3, this is the example of column matrix. Here only one column. Or we can give another one example, suppose 1, this is only one row, only one column, so this is row matrix also and column matrix also. Here is only one column, is called column matrix. Or another one example, 3 4 1, this is also a column matrix because it contains only one column. Or 4 3 2 1, suppose this is also, here is 4 row, 1 2 3 4 rows and one column, so only one column is called column matrix. I think you are clear about the row matrix and column matrix. Now let's go on the next one, square matrix. Square matrix. Matrix which have equal number of rows and equal number of columns is called square matrix. Or number of rows and columns are equal is called square matrix. Those matrices which have only one row and only one column is called square matrix. We have here square. I think let's look the example of square matrix. Oh, suppose 3. How many rows here? How many rows? One row. Row 1, column is equal to also 1. So one row and one column. So the number of row is equal to number of column. So this is square matrix. Similarly, 2 3 4 5, suppose. How many rows here? 2 row and then 2 column. So 2 row and then 2 column. So number of row is equal to number of column. This is also a square matrix. Similarly, 3 4 7 0 1 5, suppose, and then 2 6 minus 1, suppose. And how many row and how many column are here? 3, this is first row, second row, third row. So 3 row, first column, second column and third column, 3 row and 3 column. So number of row and number of columns are equal. So this is also a square matrix. Is it square matrix or not, students? Look here, 3 4 2 3 7 8 5 6. Is it square matrix or not? Can you guess this is square matrix or not a square matrix? Look here, how many row? Here 2 row and then 1 2 3 column. 2 row and 3 columns. So number of row and number of columns are not equal. So this is not a square matrix. So this is a rectangular matrix. If number of row and number of columns are not equal, then such type of matrix is known as rectangular matrix. So we can write here what is a rectangular matrix. rectangular matrix is matrix which contain different number of row and column is called rectangular matrix. Example is this one. Similarly, the next one is diagonal matrix. Diagonal matrix. Diagonal matrix हामी डिफाइन यसरी गर्छौं. इन स्क्वायर मैट्रिक्स डायगोनल मैट्रिक्स हुनलाई हामीलाई स्क्वायर मैट्रिक्स नेसेसरी छ. इन स्क्वायर मैट्रिक्स इफ द except the main diagonal elements are 0 is called diagonal matrix. Except the main diagonal elements, example हेरौं हामी except the main diagonal elements भन्नाले कस्तोलाई जनाउँछ हेर्नुस् है त. except main diagonal, suppose 1 0 0 0 5 0 0 0 7. This is a diagonal matrix. Diagonal matrix मा यो हेर्नुस् त, यसलाई हामी के भन्छौं, यसको मेन डायगोनल भन्छौं हामी यसलाई. मेन डायगोनल, this is main diagonal, and then except main diagonal other all elements are 0 is called diagonal matrix. In a square matrix हुनु पर्छ. Suppose here is no diagonal, so this is not a square matrix, so we cannot make this one is a diagonal matrix. So this is a square matrix. This is main diagonal of a square matrix. So if these and these elements are 0, then this is also called a diagonal matrix. So except main diagonal other all elements are 0. So if here this and this are 0, and then this is also called a diagonal matrix. So except main diagonal other elements are 0 in a square matrix is called diagonal matrix. Now let's look another one, 6 scalar matrix. You know what is meant by scalar matrix? In diagonal matrix, if all elements in the main diagonals are same, then that is called a scalar matrix. If all the elements in a main diagonal, suppose here is 2, here is also 2, here is also 2. So if these all diagonal elements are same, then that's called a scalar matrix in a diagonal matrix. Or in square matrix, if main diagonal elements are same and other elements are 0, is called a scalar matrix. So let's look at another one example of scalar matrix. Suppose 3 0 0 3. This is also a scalar matrix, because this is also a diagonal matrix, this is also a square matrix. In diagonal matrix, if main diagonal elements are same, then that is called a scalar matrix. So this is the example of scalar matrix. Now the next one is 7 number. In identity matrix, we need diagonal matrix, and then we join on the identity matrix. In a diagonal matrix, if the main diagonal element is unit or diagonal element is 1, then that is called identity matrix. For example, 1 0 0 1. This is 2 by 2 matrix, this is square matrix, or this is also a diagonal matrix. So if diagonal elements are 1, then that is called identity matrix. This is the example of identity matrix. Or we can write another one, 1 0 0 0 1 0 0 0 1. This is also main diagonal element here, and so this is also an example of diagonal matrix. We say unit matrix also for identity matrix. This is the example of identity matrix. Now the next one is null matrix. Null matrix, or we say zero matrix. If all the elements in a matrix is 0, so that is called a null matrix. Suppose 0 0 0 0, this is a null matrix. Or we can write 0 0 0 0 0 0 0 0 0. This is also example of null matrix. If all the elements in a matrix is 0, is called a null matrix. Now on 9 number, we have another one, triangular matrix. Triangular matrix. Triangular matrix are divided into two parts. That is, one is upper triangular matrix, upper triangular matrix, and another one is lower triangular matrix. So at first, upper triangular matrix. At first, triangular matrix in square matrix, if the element upper than the main diagonal is 0 or lower than the main diagonal is 0 is called a triangular matrix. So upper triangular matrix is the matrix in a triangular matrix or in a diagonal matrix if the element below than the main diagonals are 0 is called upper triangular matrix. Suppose 2, 3, 4, 0, 7, 5, 0, 0, 6. Suppose in this matrix we have here, this is the main diagonal and this element just below the main diagonal is 0 is called upper triangular matrix. Now about the lower triangular matrix. Lower triangular matrix. What is meant by lower triangular matrix? In a diagonal matrix, or we can say in a square matrix, if the element upper than the main diagonals are 0 is called lower triangular matrix. Suppose 1, 0, 0, 2, 4, 0, 7, 6, suppose 9. So here this is the main diagonal and the element just above the main diagonal is 0 is called lower triangular matrix. And the lower triangular भन्नाले main diagonal माथिको element 0 भयो भने that's called lower, अनि main diagonal भन्दा तलको element 0 भयो भने that's upper, just opposite जस्तो छ. त्यसकारण यो कुरा तपाईले सम्झिन सजिलो पनि हुन्छ. त्यस्तै गरी on number 10, transpose of matrix. Transpose of matrix. This is transpose of matrix. This is not a types of matrix. Now in transpose of matrix, if we change row into column, column into row, that's called a transpose of matrix. For example, 2, 3, 5, suppose 3, 7, 8. Okay, just look here. If A is equal to this 2, 3, 5, 3, 7, 8, and then how to transpose this matrix row to column, column to row. Here 2 row and then 3 column. So 2 row and then 3 column. So A transpose means AT, will write AT like this. So this one is, this 2, 3 is here, so 2, 3 we write like this, 2, 3, and then 3, 7 is, we write 3, 7, and then 5, 8 is 5, 8. So what is the order of this matrix? 1 row, 2 row, 3 row, and then 1 column, 2 column, 3 row, and then 2 column. Let's look here. Row to column, column to row. So if we transpose row to column, column to row, that's called a transpose of matrix. So here this again we can look another one example. Suppose B is equal to 2, 0, and then suppose -1, -3. How to change this one? B transpose is equals to 2, 0. We can write 2, 0, and then -1, -3. This is transpose of matrix. B transpose is 2, 0 is here 2, 0, -1, -3 is -1, -3. Here row, at first 2, 0 is row, but here 2, 0 is in column. -1, -3 in row, second row, and -1, -3 in second column. So row transpose into a column. in this way. If we'll double transpose, then if we'll transpose B transpose, again if we'll transpose this here 2 0, we can write like this, and minus 1 minus 3. If we'll double transpose, then it will be a matrix B. If we double transpose, then that is a same matrix B. So transpose of transpose matrix is the original matrix. So you know about this transpose matrix also. Students, now we are going to start operation of matrix. Operation of matrices. In operation of matrix, we add, this is addition, subtraction, and multiplication. And division also we can do, but here we focus at most addition and then multiplication. So at first, addition of matrix. If A is equal to, suppose 2 3 4 5, and B is equals to 1, suppose 1 1 2 2, if A and B are of same order means this is also 2 by 2 matrix, this is also 2 by 2 matrix. If the order of two matrices are same, then we can add these two. So A plus B is equals to, this is 2 3 4 5 plus 1 2 2 2. So its result is 2 plus 1, 2 plus 1, 3 plus 2, 3 plus 2, and 4 plus 2, and then 5 plus 2. In this way, and this is 3 5 6 and 7. This is the addition of this, and its order is also 2 by 2. So if the order of A is 2 by 2 and then order of B is also 2 by 2, then A plus B is also the same order of A and B. So in this way we can add matrix. Now subtraction of matrix. Suppose A is this and then B is this, then A minus B is equals to, matrix A is here 2 3 4 5 minus B is 1 1 2 2. Then if we subtract 2 minus 1, 2 minus 1, and 3 minus 1, 3 minus 1, again 4 minus 2, 4 minus 2, and then 5 minus 2. So this is equals to 1 2 2 and 3. This is the subtraction of matrix. And if order of A is 2 by 2, order of B is also 2 by 2, then order of A minus B is also same. So order of A minus B is same as order of A and order of B. This is very easy. So I gave only just simple example of addition and subtraction. Now we are going to discuss about the multiplication of matrix.